G'day team, welcome back to another video, and today we're going to start looking at domain and range. Now these two things are really important for looking at graphs and sort of limitations and limits and bounds on our graphs and what values our x and y can take. Now the domain is the set of values the function can take on the horizontal axis or on our x-axis. The range is the set of values the function can take on our vertical axis, so our y-axis. So, just a little bit of notation, okay? So, remember these points are inclusive because they are solid. So, for numbers between a and b inclusive, we write a is less than or equal to x, which is less than or equal to b. Now, they can be equal to that because it's included, okay? The opposite of that is when they're excluded. So for numbers between a and b exclusive, we write a is just less than x, which is less than b, because it cannot be equal to that point. All right. If I had a solid point here, so it could be equal to b, then we'd have something that looks like this. Okay, so it can be both. Now, the final thing is when we have arrows on either end, so that means they go off forever. So for graphs that go off on forever in a direction, we say x is in the set R. So R is our real number set. So that means from up to infinity, basically. So any number you can think of, x can be it because of this arrow. All right. So let's do an example. So I've got three functions here, the red, the pink, and the orange, and we're going to write the domain and range for each function. So for the red one, let me just jump back to black. We need to look at the domain, which is our x values. We write x such that, and then we write the condition for x. Now, for my red one, we have an exclusive point here, and it's at -10, so x equals -10, but it can't be equal to that point, so we just say less than, all right? And then on this side, it's shooting off into infinity, so we say x is in R. So we have two conditions on our function here. X cannot be less than -10, so it has to be greater than -10. And other than that, x is in R. Okay, so there are our two conditions. And our range, so the lowest point for our red function is here, which looks like about -7.5. So for range, we got y, so -7.5. Now that's inclusive because it doesn't have a hollow dot on it. All right, and then that one also goes off indefinitely, so y is also in R. Okay, for our pink one, all right, our domain, so looking at our x values again, so this looks like it goes off indefinitely this way, so we've got x, so x is in R, but then we look at the upper bounds, and I haven't drawn this very great, but that's supposed to be at 10. So that means x is less than or equal to 10 because that is an inclusive point. Now for our range, okay, the lowest it can be is -10. Okay, so drawing our brackets, y, so y has to be greater than or equal to -10, okay, because that's inclusive, that point, and then y goes off indefinitely in the upper bounds, okay? And then finally our orange one. So the leftmost point for x that our function takes is -5. So x, so -5 is inclusive. So -5 inclusive means less than or equal to x. And we have an exclusive point at +5. So we write just less than, not x, we want 5. Okay, so there's the inclusive and exclusive part. And now for our range, so we've got y. The lowest our function goes is -5 as well. So -5 is less than or equal to y. And then inclusive up the top here, this is our highest point, and that's at 10. So less than or equal to 10. Okay, so there's three very different examples from each other, all on the same set of axes. So it's really important we're identifying what is happening at each end so we can determine the correct domain and range. So with that, hopefully that sets you up to have a crack at some questions, and we'll see you in the next video.